Hello everyone, myself Anita, Assistant Professor, Department of ECE. Today we are going to see about the architecture of 8086 microprocessor. So, what is microprocessor? First we are going to see about the introduction. So, this 8086 microprocessor is a 16-bit microprocessor designed by the Intel Corporation. So, it is the first member of processor in 8086 family of microprocessor. So the architecture of 8086 microprocessor is a CISC architecture, that is complex instruction set architecture, which means that it supports a wide range of instructions, many of which can perform multiple operations in a single instruction. So this 8086 microprocessor has a 20-bit address bus, so which can address up to 1 megabyte of memory, and a 16-bit data bus which can transfer the data between your microprocessor and memory devices. So this is the architecture of 8086 microprocessor. The main functional units of 8086 microprocessor is bus interface unit and execution unit. Here the bus interface unit, this is the execution unit. The next one is bus interface unit. So this bus interface unit fetches the instruction, reads the data from the memory and IO ports, and write the data to the memory and IO ports. The BAU contains segment register, instruction pointer, instruction queue, and address generation unit and bus control unit. Here the execution unit execute the instruction that have already been fetched by the bus interface unit. Here the bus interface unit and execution unit function independently. This architecture is pipelined architecture. So pipeline architecture means the processor will have the number of functional units and the execution time of each functional unit overlaps. Each functional unit works independently most of the time. So first we are going to see about what is bus interface unit, execution unit, what are all the blocks available in your bus interface and execution unit, and the main function of each block. Okay, so first we are going to see about the bus interface unit. The function of the bus interface unit is fetches the instruction, read the data from the memory and IO ports, and write the data to the memory and IO ports. Here the bus interface unit consists of the address generation unit. This address generation units develop a 20-bit physical address by using the help of the segment register. In bus interface unit, there are 4 segment registers are there. One is code segment, data segment, stack segment, and extra segment. So this BAU develop the 20-bit physical address. How it developed this 20-bit physicals we are going to see. Next, so first one is segment register. So the 20-bit address generation can be obtained by the content of code segment register is logically shifting left by 4 times and then adding it to the content of the instruction pointer. First we are going to see about the bus interface unit. So bus interface unit, there are 4 segment register. First one is code segment register. So code segment register is a 16-bit register. It contains the base to start of the current code segment. So the BAU computes the 20-bit physical address by logically shifting the content of this code segment 4 bits to the left and then adding to the content of the instruction pointer. So next one is data segment. This data segment register calculate the physical address by taking the 16-bit content of source index register or destination index register or 16-bit displacement value. So it will calculate the 20-bit physical address. Next is stack segment register. Here the 20-bit physical address is calculated from the stack segment and stack pointer for the instructions such as push and pop instructions. If the push instruction is executed, the content of the stack pointer is automatically incremented by 2. When the pop instruction is executed, the content of the stack pointer is automatically decremented by 2. The next extra segment register. So this register, the 20-bit physical address is calculated by using the data segment value. So here it uses the either extra segment or destination index register for calculation of 20-bit physical address. Next one is instruction pointer. So the instruction pointer is 16-bit register. So this instruction pointer is always point the address of the next instructions to be executed. So the instruction pointer uses instruction pointer. It is also a 16-bit register. This is used to point the address of the next instruction to be executed. So the instruction pointer uses FI FOQ, that is first in first out group of registers. The size of the queue is 6 bytes. That means the BAU, that is your bus interface unit, fetches the instruction code from the memory and stores it in the queue. This execution unit fetches the instruction codes from the queue. So next one is instruction queue. This instruction queue automatically, that is the group of first in first out queue is here used. This is done in order to speed up the execution by overlapping the instruction fetch with an execution unit. Next one is execution unit. So in this execution unit, what are all the blocks are there? First one is general purpose register. So the EAU has 16-bit ALU to perform the arithmetic and logical operations. This EAU has 8 number of 16-bit general purpose register, that is AX, BX, CX, DX, SP, BP and SI and DA. SP means stack pointer, BP base pointer, SI source index, DIS destination index registers. Next, it contains the flag registers. So this flag registers, your 8086 microprocessor contains 9 additional flags, 9 control flags and 9 general purpose flags and 3 control flags. So this is the overall block diagram, that is functions of your 8086 microprocessor. So here the 16-bit ALU perform as usual arithmetic and logical operations. Here 4 segment registers are there, AX, BX, CX and DX. So here AX can be used as a 16-bit register, or it can be used as a 2 8-bit registers. So that's all about your architecture of microprocessor. Next class we are going to see about the flag registers of 8086 microprocessor in detail. Thank you.